Hi everyone. In this video we're going to talk about section 4.5, which has to do with inequalities again, but this time it's inequalities with quadratic equations or functions. Okay, and so they're going to be a little different. We're going to have to solve them differently than we did with the linear functions that we dealt with in section 1.5. So let's take a look. When we solve inequalities that include a quadratic equation, like you see below here, x squared minus 4x minus 12 is less than or equal to 0, there's no good way to solve it like we did with linear functions. The easiest way to solve one of these inequalities is to actually graph this function, which we know how to do. Okay, we need to graph this function and then determine where it meets the inequality. Okay, so for instance, this equation, we're going to graph it. It's going to look something like, if we have this, maybe it'll look like this. Okay, and so we need to see where the graph is less than or equal to 0. And so we'd say, well, it's less than or equal to 0 from here to here in this range. Okay, and so then that would be our answer. X has to be between -1 and 4 or something like that. Okay, so that's what we're going to do. First thing that we need to do is graph the actual function. Okay, and so to graph the function, we need to find all the stuff that we did before when we worked on graphing quadratic functions. So we need to determine its concavity. Okay, concavity, that's when you look at the first, the coefficient on the largest term. If it's positive, it's concave up. So this is concave up, which means that the parabola opens upward. Okay, so it's concave up. The vertex happens at the point negative b over 2a, and then you substitute that into the function f of negative b over 2a. Okay, so to do that, this is the coefficient in front of x squared is a, coefficient in front of x is b, and then coefficient in front of, well, 0, nothing, is c. Okay, so negative b over 2a is the opposite of negative 4, which is 4, divided by 2 times 1, 2, and 4 divided by 2 is 2. Okay, so the vertex happens at 2, and then I substitute that into the equation here. So f of 2, where f of x is x squared minus 4x minus 12. Okay, I substitute in 2, so I get 2 squared minus 4 times 2 minus 12. So that's 4 minus 8 minus 12, which is negative 16. Okay, 4 minus 8 is negative 4. Negative 4 minus 12 is negative 16. Okay, so the vertex happens at 2, negative 16, and it's concave up. So we have a starting point. Okay, we have a starting point here, and now I'm going to have to draw 16. Okay, so I drew 16 lines there. Okay. I know this is not my greatest drawing. The graph does matter, and we'll see why later, but it's not really imperatively important. So 2, negative 16 is this point right here. Okay, so that's our vertex, and it opens up. The next thing that we need to do is find the x. We don't really need to worry about the axis of symmetry, which I also would ask you to create. We need to find the y-intercept. Okay, so the y-intercept might be important here. So if you look at the y-intercept, that's really just f of, I plug in 0 for the function, okay, and you get out negative 12. Okay, all the x stuff goes away. You're left with negative 12. So it's 0, negative 12. Okay, so I think that's here-ish. Although I can't seem to count very well. That might be 11, might be 12. But the y-intercept isn't really important. What we're looking for is when x crosses, when x is, or when this whole thing is less than 0. So really what we're interested in are the x-intercepts, where it crosses the x-axis. Okay, so the x-intercept we find by setting the function equal to 0 and then solving and finding those x values. So what we need to do is factor x squared minus 4x minus 12 so that we can solve with the methods that we've been using. And so when you do that, you need two things that multiply to negative 12 and then add to negative 4. And so that's minus 6 and plus 2. Minus 6 and plus 2. And so you can check that out. So the possible solutions, or the solutions for this equation are x being equal to 6 or x being equal to negative 2. Okay? And so the points, the x-intercepts, are negative 2, 0 and 6, 0. Okay? So if we draw them, 6, 0 is right here. So if you can hear me counting, I do have to count over. And then negative 2, 0, which is here. Okay, and so then if we graph to the function, it's going to look like something like this. There. Okay. And what we're interested in seeing is where the function is less than 0 at. Okay? Less than or equal to 0. And so where is the graph of the function below the red line? Well, it's there for all of this. Okay? Where are the endpoints? Well, it's easy to see that the endpoints are those x-intercepts. Okay, so the answer, we'll put the answer down here in this red box, is the interval being between and including negative 2 to 6. Okay, so you see those x-intercepts really helped us out. It was below 0 from negative 2 to 6, including both, okay, because at negative 2 and at 6 it is 0, but if you look up here at the original inequality, we're looking for things that were 0 or less than. Okay, so that's how you solve that. If you were to write this in interval notation, you'd write negative 2 to 6 with brackets. Okay, and so there's our answer. Okay, and we don't really need to draw a number line because we can see it in the graph over here. Okay, so there's one example. Let's do a second example just to get it down before I ask you to do one on your own. Solve the inequality 2x squared is less than x plus 10. When I have an example like this, I want to get everything over to one side and have 0 on the other side. Okay, because 0 is nice on the right side, because that I can use my x-intercepts. But if I have something weird over there, like 10, that might be quite hard to see where it crosses the line y equals 10. Like, it would be a nightmare. So we always want to get 0 on that right side. Hence, we subtract x and we subtract 10 from both sides. And we get 2x squared minus x minus 10 is less than 0. Okay? So the inequality stays the same because I haven't divided by a negative number. So again, we do the same game as we have been. The number in front of the largest term is positive, so it's concave up. It's concave up, okay? Vertex here happens at negative b over, excuse me, 2a, and then at f of b of negative 2a, okay? The function, keep in mind, is 2x squared minus x minus 10. And so b over 2a, negative b over 2a, is negative 1, the opposite of negative 1, over 2 times 2, okay? And so that's 1/4. 1/4. So the vertex happens at the point 1/4, okay? And then you substitute that into the function, okay? And that's going to be a little bit tougher here, but we can do it. 2 times 1/4 squared minus 1/4 minus 10, okay? And so you don't have to necessarily do this, you don't have to keep this as fractions. You can plug it into the calculator. I don't care that you can't go through this as all fractions, but I'm going to, just because I don't have a calculator and it's easier for me, okay? 1/4 squared, the squared goes to both the 1 and the 4, so I've got 2 times 1/16 minus 1/4 minus 10, okay? If I multiply the 2 by the 1/16, I get 1/8 minus 1/4, I can change to 2/8, right? Those two things are the same. I've multiplied the top and the bottom by 2, minus 10, which is 80/8. Okay, so I've just changed so that everything is divided by 8. Because I have like denominators in my fraction, I can add or subtract the numerators like it says, and so I have 1 minus 2, which is negative 1, and negative 1 minus 80 is negative 81. And so the number here is negative 81/8. Okay, so I know that's weird for a vertex. It's a little over negative 10. Okay? So that's my vertex. And so if I want to erase this and draw my thing here. Oh, excuse me. Okay, so we've got now our x and y axis, and it happens at 1/4, which is basically 0, or it's hard to tell on the graph. Down here at slightly more than 10, so it's down here-ish. Okay, so that blue dot down here. Okay. That's not really the most important part. The most important part are the x-intercepts. So I'm seeing where it's less than 10. I've got a vertex. It's concave up, so it's going to be going up this way. So eventually it'll cross the x-axis somewhere down here and somewhere up here. What we've got to do is just see where those points are. So the y-intercept is not going to help us, so I'm not even going to try to calculate it. But what we do need are the x-intercepts. And so to get the x-intercepts, I need to solve the equation 2x squared minus x minus 10 is equal to 0. Okay? So to do that, I can do a number of different methods that we've learned so far. You can choose either of them. One possible option would be to divide both sides by 2, and then I'm left with x squared minus 1/2 x minus 5 equals 0. Okay, but then you'd need two things that multiply to negative 5 and add to negative 1/2. Okay, and we could try to reason through that, but that's no fun. So why don't we use the sort of tried and true method of the quadratic formula to do this. And so to get to use the quadratic formula, we have A, B, and C. A, B, and C. A is 2, B is negative 1, C is negative 10. Okay, so it's quadratic formula for reference is negative b plus or minus the square root of b squared minus 4ac over 2 divided by a. Okay, so we have the opposite of negative 1, which is positive 1, plus or minus the square root of 1 squared minus 4, negative 1 squared minus 4 times 2 times negative 10, okay, all divided by 2 times 2, okay. So I've used up a lot of the room here, but I'll do some more calculations at the bottom. 1 plus or minus, and then if you look inside the square root, you have negative 1 squared, which is 1, okay, plus, if you do 4 times 2 times negative 10, that's negative 80, and so you have minus 1 minus negative 80, and so that's 81, okay, 81. So I've got the square root of 81 over 4. And the square root of 81 is nice because it's 9. Okay, so then if I move all the way up here, I've got 1 plus or minus 9 divided by 4. So the two answers are 1 plus 9, which is 10 divided by 4. So that would be 10/4 or 5/2. Okay, or 1 minus 9, negative 8 divided by 4 is negative 2. Okay, so we've got negative 2 and 5/2 are my x-intercepts. So if we go all the way down here, I've got to erase some of this work and erase that. The points are at 5/2, which is 2.5, okay? So it's in here, 2.5 and negative 2, which is right here. Okay, so the function is going to look like this. When is it, back to our original problem, up here, when is it less than 0? Again, if we shaded in that portion, it would be this. Okay, but not including those points at 0. So, final answer, and I'll erase a little bit more of this quadratic formula here. The final answer in the red box is x between, but not including, 5/2 and negative 2, or I would write that as negative 2 to 5/2 with parentheses around them. Okay, so that was different from our last example where there were brackets. Now there's parentheses. Okay. All right, so now we've had 2 examples, so let's look at a your turn. Okay, so here I've got the inequality, and so you need to find the vertex. Do x-intercepts exist? How do they look at the inequality? Okay, so this should be not an easy one, but also not too challenging, hopefully.